properly. 1, 2, 3, and 4 buses of a system interconnected by some fashion. Okay, then I will just mention, I'll take a very simple problem first, so that later we can apply this concept to the little complex problems and we can solve for the requirement. That is Y bus by singular transformation method. This is bus number 1, this is bus number 2. No matter where they are located, what matter is the identity which is properly mentioned. So bus 4 is mentioned as reference bus in the problem. It is mentioned. Then you have been given connectivity and you have been given information like this table, line, you have connection, connectivity, then you have admittance. You have been given in the form of table. Okay, I just write a table. This is one table. You have been given, how many lines are there? 1, 2, 3, 4, 5. There are 5 elements. So it is labeled like this way. Element number 1. What is this? It is connected between 1 to 4. 1 to 4 means 1 to 4. This element is 1. I'll put it later. Then admittance is given as in the per unit notation, PU. So simply I write absolute value of it for the initial workout. Then element number 2 is mentioned as 1 to 2. 1 to 2 whose admittance is 1.6 PU. And element number 3 is mentioned as connectivity between bus 2 to bus 3, which is having a value 2.4. This is a very simple problem. Such simple problem even we will work in laboratory also using MATLAB. Write a MATLAB code to obtain Y bus by singular transformation method for the given problem like that. You have to generate a program. So that program becomes a generic one whenever we pose the content which are changing. So it should be able to evaluate the Y bus of that using the principle. Then the fifth element which is mentioned in this problem is between 2 to 4. So I read out and I will explain you what is this exactly. Okay, and obtain Y bus. So Y bus by singular transformation method. So you have been given a problem. You have been given a problem. The problem is having 4 buses in the interconnection. Then you have 5 elements in which you have interconnection. Then you have line data in admittance PU, which is quite easier for us now. We have 5 elements. So element number 1, which is 1 to 4. Now I should trace. 1 is here, 4 is here. Element number is 1. So this is marked as 1. Like this. Then 1 to 2. This is element number 2. So 1 is here, 2 is here. So I should mark it 2. In the earlier discussion, how to mark the number, how to give a orientation, that was the question. So no matter, however it is mentioned, we need to adopt. So but for me here, 4 bus system, 5 elements are there. Simply I have been given a table. Table I'll adopt. This became element 1. This automatically became element 2. Element number 3 or line number 3 is between 2 and 3. Where is 2? 2 is here, 3 is here. This element now turns to be 3 for me. Then 4th element, line number 4. Element 4 is 3 to 4. Where is 3? 3 is here, 4 is here. This element turns to be element number 4. Then 2 to 4. 2 to 4 is, where is 2? 2 is here, 4 is here. This diagonal line. Okay. This turns to be 5th element for me. So by this way, from the given table, I will be able to make out the diagram. I would otherwise say, this diagram need not be given to you. Still you can work with the problem itself. Or table need not be given to you. If this data is mentioned on the lines itself, you must be able to get that. So we will see how it can be done over a step or over a work in a short while we will come to know. So this is the problem. A 4 bus 5 element system with the connectivity diagram and information. Obtain Y bus of this system using singular transformation method. Now once you look at the problem, look at the data. Is the data is in admittance or impedance? Yes, it is in admittance. one step is very easier. No need to take inversion of any of the elements. That's the first observation. The second observation over here is this system is having any mutual coupling? No mutual coupling. Nothing is mentioned. Any of the element is mutually coupled to any of the rest or remaining elements. Such kind of connectivity is not pronounced. Hence, it is quite easier. So, I would say there is no mutual coupling between elements in this problem. So, that is quite easier for us. Okay. So, therefore, what is next step for me? Look at the problem solution. So, we have Y bus equal to, may I know it? A transpose Y primitive into A. This is the formula. A transpose Y PRI or Y into A. What is this A matrix? Reduced incidence matrix of the problem given. What is A cap or A bar, if you could see? This is called full house matrix. From this, one of the row or a column referring to reference bus is removed. That remains as a for me. It means for me now very basic requirement is obtaining A matrix of the given problem from the given parameter. Then next is representation of the elemental admittance matrix. So I should prepare Y primitive, I should prepare A matrix, take A transpose of that, put them in the line and operate mathematically. That would lead to me the Y bus of this particular problem. So let us begin with this formula. Let us try to make what is Y PRI. How to make Y PRI? Primitive element matrix of this problem is by dimension. So how many elements are here? Total 5. This element means this matrix stands to be 5 cross 5. It must be 5 cross 5. And this matrix A and A transpose, whatever I used over here, I need to obtain from the problem. Let us do one by one. Let us make Y primitive first and A later, A transpose, put them in the sequence and take off the mathematical one. Okay, I begin with this. So I place here, we have Y. You can see lowercase y I am writing, which is equal to a matrix of 5 cross 5. 1, 2, 3, 4, 5. There are 5 elements and there are 5 elements this side also. So I write here, what is element number 1? 1 cross 1. 1 cross 1 is element number 1 whose admittance I should mention. It is 1.4. And element number 2 is 0, 3 is 0, 4 is 0, 5 is 0. So I close the bracket. Let me do it here and come to you back. Okay. How about element number 2? Element number 2 is 1 to 2, which is 1.6. So element number 2 means it should be 2 cross 2. If I write over here also 1, 2, 3, 4, 5. So 2 cross 2, this position, nothing but 1.6. So this works out here 1.6. How about remaining things here? As there is no mutual coupling in this problem, remaining elements other than main diagonal elements like 1, 1, 2, 2, 3, 3 till the last one, rest of the elements remain 0. Therefore, I should mention without fail 0 over here, 0 over here, 0 over here, 0 over here. Hope this is possible. Similarly, what is 3 cross 3? This element I am speaking. 3 cross 3. 3 cross 3 means element number 3. What is element number 3? Connectivity 2 to 3. Element number 3. Line 3 or element 3 is one and the same for me. Line 3 is 2.4. So I should go 1, 2, 3. This is 2.4. How about the remaining elements? I should fill them without fail zeros because there is no mutual coupling explained in this problem. If there exists a mutual coupling, I should take care of that one. So I'll admit your friends. Some of the friends are waiting for me to get admitted. Okay, fine. Okay. Then 4 cross 4. I am waiting for this element. Element number 4. It is 2. So I position 4 cross 4 this as 2.0. 0 over here, 0 over here, 0 over here, 0. How about the fifth element? 1.6. No matter whatever the data is given, if it is an admittance, it must fall on the diagonal unless there is a mutual coupling. If there is a mutual coupling, other than this diagonal, few of the elements in the upper triangle, lower triangle of the representation will be surely non-zeros. Therefore, I should take this element number 5, which is element 5 with the data 1.6 in the 5 cross 5 position, which is 1.6. Rest all are 0 without fail because this is non-coupled case. So you just observe, you have 5 element system, 5 cross 5 matrix is ready for you. So you have filled all the elements of the particular problem on the main and diagonal and kept your Y primitive ready. Now what is your next task? When you have kept ready with the Y primitive, you have to prepare A matrix and take A transpose of that, put in a string. Like Y bus of a system is A transpose multiplied by Y primitive multiplied by A matrix of the problem. Hence, when I resolve mathematically, what it leads to me is a particular Y bus of a system. And I must be known to very clearly, if I have 4 buses in this, when I want to work a singular transformation method, which is the reference bus given, you must check without fail. You can note here, when I was drawing, I mentioned you 4th bus as reference. When 4th bus is a reference, when I want to obtain Y bus of this system, what would be the dimension of the resultant matrix? The resultant matrix shall have number of buses minus the 1. The minus 1 is because of reference bus has to be taken out of that consideration. If it is done by a Y bus by inspection method, the same problem if I do it by inspection method, Y bus dimension shall be whole matrix. This is 4 cross 4. That time reference concept won't be there. Only in singular transformation method, when we take transformation of network variable and parameters into a meaningful admittance matrix, singularity of matrix A comes over there. Hence, to get that singularity of matrix, A matrix has to be formed from the A cap. Hence, reference bus has to be deleted from that representation. So, no matter, we must remember syntax, singular transformation, reference bus must be identified from the given problem. So, here 4 is a reference. Now, my next task is to obtain A matrix for this. How to obtain A matrix for this? I should draw oriented graph. There is no arrow mentioned here. You might ask me, how can I draw? You recall back to my interaction. If you have been given orientation, use them. If you have not been given orientation, you can assign and you can conclude till the problem. No question comes, there is no arrow marked. Then how to take the arrows? So how to take the arrows? The question comes. So I should refer from my orientation. I have a simple trick. I may give randomly. However I want orientation. I stick on to that. I complete it. The one technique. The other technique is I can follow this technique. 1 to 2. I can put the arrow this way. 1 to 2. 1 to 4. 1 to 2. 2 to 3. 3 to 4. 2 to 4. Like this also. This is an easy trick. It need not be the syntax of this work. It is just a method. So I want to make the left corner of this connectivity called bus connectivity. P to Q. P is 1, Q is like that. 1 to 4. 1 to 2. 2 to 3. 3 to 4. 2 to 4. This is a way of interaction. You may do this way. Nothing wrong if somebody does this way. I don't want to follow your method. Why I should follow? I should follow the best which is easier to me this way. What is this? Exactly opposite to my process. You would like to take connectivity 4 to 1, 2 to 1, 3 to 2, 4 to 3, 4 to 2. You use it, nothing wrong in that. Use it, conclude it till the problem completes. In between, do not change your orientation. So this is also valid method. If you don't want still, why I should follow a systematic way, left to right or right to left? I want to do any arbitrary way. I would like to give some direction, however I like. Still you are accepted. Provided in the basic problem, you have not been given an arrow, you have a choice, arbitrary choice of your direction. So I said method 1 is making bus left to right side movement or right to left movement are the best way. Otherwise also any arbitrary convention if you could put on the representation, still you are able to work out. Hope it is clear to me. And now I will move. I will not follow this also. Whatever the method I said just now, I will not follow. Let me go arbitrarily. As somebody say, we should follow arbitrary. Later we will stick on this. In the laboratory, we will be following this method because in the MATLAB program, I have to read sequentially from to like that. There we will learn something new. So here, to do this, what I will do? This problem I will transform as a connected graph. On that graph, I will draw orientation. Then I will form a matrix from that. To do that, I just take this portion out. So what I will do? I just draw graph of this. I just put an arrow. I draw the graph here. How I draw the graph? Look into this. I just try by representation. 1, 2, 3, and the another one. I represent this as a 4 and this as a reference. And this as 1. I put as 1. I put this as 2. I am transforming this connectivity into graph. So I have 4 nodes or 4 buses. 1, 2, 3, 4 I have marked. Now I have to connect the elements like this by edges. How I do it? There is a connectivity between 1 to 2. There is a line. How I will draw it? Just look. 1 to 2 there is a connection. I just do. And 2 to 3 there is a connection. Any element number I just do. Then I have 1 to 4 this way. I can do randomly also, but I should see, I should follow all the connections. 1 to 4 is there, 1 to 2 is there, 2 to 3 I have done, 3 to 4 I will do, 3 to 4 I will do. And I have 2 to 4 also. I will draw it a little closer. Okay. How many elements I have now? 1, 2, 3, 4, 5. I label the elements. 1 to 2. This is number 2. This is 2. 2 to 3. This is element number 3. 1 to 4. This is element number 1. 2 to 4. This is element number 5. 3 to 4. That is element number 4. You can see 1, 2, 3, 4, 5. Like that diagram, I generated a graph. Now I have to give orientation to this. So I have given random orientation. I said a technique left to right or right to left which can be followed, or else any arbitrary orientation can be used. Let us do arbitrary. Let us see what happens. I have worked with numerically like this way. I have marked randomly like this, and upgoing and another upgoing arrow. I have clearly said any orientation you can follow. Still someone would like to follow the principle which I said, left to right or right to left. If you follow it till the end, I convince and I guarantee you both of us meet the answer. The last step answer of mine and yours must be one and the same. There is no doubt about it. Okay? That we can test in the laboratory when we come with a numerical work of that. So I have just given arbitrarily. So 1 to 4 I marked, 4 to 1 upgoing, 4 to 2 upgoing, 4 to 3 upgoing, 1 to 2 rightward, 3 to 2 to 3 rightward. So I did not follow the method itself. Left to right convention, right left convention, which I specifically pronounced, I not followed it. I followed in an arbitrary way like anyone. So still it will work for me. So let us begin this. So acceptable. Now when I have a buses respectively, arrows mentioned arbitrarily, now I have a choice to make A or A cat. So when I want to make a full house matrix, 1, 2, 3, 4, all the buses, all the elements I should consider, delete the column of 4th bus, which is a reference bus. So let us do it. So from this, I put an arrow, I make A matrix. What is A matrix for me? A matrix is element node impedance matrix. How many elements were there? 1, 2.
Excuse me.
Please reply to me, please. I am ready to listen to you, please. Element node matrix, which is having number of elements 5, number of buses I put as 1, 2, I put 3 and 4. Hope this is visible? Yes, it is visible in the screen. So I just put a bracket over here. Okay. So it is 5 cross 4. This side I have buses. N is bus for me. E is element for me. N, E. So when I want to write this particular A, this I should delete. What I should do now? Initially I put cap. So that I have considered 1, 2, 3, 4. After doing this one E cross N, I delete this. That time a cap I will delete it for me. So first let me say a cap. From that fourth column, which is a reference bus, I remove. That automatically becomes A matrix for me.
Okay.
Yes, please. I am able to listen. Please reply to me.
Sir, repeat the directions of the.
Okay. Okay. So directions, how I marked on this problem, I was repeating you earlier. There may be a standard way to follow for the engineers. There is no textbook say how to follow the direction. That's the first understanding. But there are some tricks to follow the direction if the basic problem is not given any orientation, not given. Then how to do it? There are two methods which people prefer. The method is from the table of connectivity, where from to buses, bus 1 to 4, it's called from bus to bus. From bus to bus, like that, it will be a connectivity we can understand. From this identity, how we can take advantage? The easy way is you can give from bus towards this way arrow. Means from to, you can put the arrow. Means 1 to 4. 1 is here, 4 is here. You can put the arrow like this. And you should follow the sequence 1 to 2. From 2, again you should mark this way. And 2 to 3, this way. 3 to 4, this way. And 2 to 4, this way. Whole work you have to follow simple, single type of orientation. Means from bus to 2 bus, from bus to 2 bus, from bus to 2 bus, so called. You can follow this way. If it is the way you have identified that you would like to mark the arrows on the given problem from first column, which is bus from, to the next one to destination bus, where to where there is a connectivity. This kind of arrow you would like to follow is your arbitrary method. This is one way. Accordingly, you have to put the arrow. In my diagram, I have exactly put opposite. So then I can put 1 to 4. Can you see here? 1 to 4. With 1 it should leave, 4 it should land. It should go in this way. Why I mark this way? Because this answer I wanted to give you ready. On my note it is already done arbitrarily. If suppose somebody want to do of their own, I have just randomly put it. I can show this way also. Okay? If this is the way, I should suppose this is the way, let me do it. Nothing wrong. Later I will change my direction. I will change the direction and I will do it. Because I have to ask the answer from you that I am avoiding. That's the only thing. For you, if this is the method, how it will look like, I will convince and I will come back. I don't have any problem. Okay? Is it back to my work again? Okay? If this is the method, how I should do? 1 to 4. 1 is here, 4 is. This must be the arrow. This way. Then what is the next line? 1 to 2. This must be the arrow. I make it short. What is the next line? 2 to 3. 2 is here. Where is 2? 2 is here. 3 is here. This must be your arrow. Then what is this? 3 to 4. 3 is here. 4 is here. I should make this way. How about the next one? 2 to 4. 2 to 4. Okay? If I follow from to concept, your graph would look like oriented in this way. If this convention is clear to you all, suppose if I follow method 1, which is one rough practice by some people. This would be your representation. You should use it to form a cap, remove the column of your reference, use this till the completion of your problem. That's what we have to stick on. This is one of the methods. The other method I was telling you was changing the direction. I don't want to follow this. I want to follow this way. I want to follow this way. So this is exactly opposite to my convention, which is there on the board. Opposite I am going, where I am doing 4 to 1 I am marking. Can you see here how it looks like? I remove them. I remove it, I will show you how it works. Okay. When I join them as usual, this is just a graph. When I want to take orientation like this way, 4 to 1. 4 is here, 1 is here. This is the one. Then 2 to 1. Where is 2? 2 is here, 1 is here. Is it okay? Then 3 to 2. 3, 2. 3 is here, 2 is here. Okay? Then 4 to 3. 4, 3. 4 is here, 3 is here. So 4, 3. Then last is 4, 2. 4, 2. 4 is here, 2 is here. Oh, this is clear. This is another way of doing. How you do it? From to destination bus to connecting opening bus. Opening, closing. Opening, closing. Start, finish. Start, finish. This way. So you took exactly opposite. Still you are correct. No matter how you took it. But you have to stick on to this complete till your completion of the problem. So if I do this way, this should be the problem. Okay. So both the ways I have marked it. It should convince you. What I have marked before this was arbitrary. Suppose I don't want to follow this, whatever the method you prescribed, method 1 or method 2, I would like to do my own. Then you are permitted. But you have to stick on to that till the end of the problem, which I was presenting you on the board. Because I have already taken this answer on my calculation, so that I need not ask you to give the answer. I can do it once. Later I can convince you this can be done other way also. So this is clear to you. Okay, I come back. Hope this is clear your problem. One of your friends asked me.
Yes, sir.
Okay, thank you then. I'll go back to my old one because that answer is readily available in my notes. It will be easy for me to proceed with the next problem. Okay, I'll save some time over there. Okay, so I'll come back. So I'll come back once again with my original problem. I'll convince you. Okay, I'm redrawing it. Okay, this was my original diagram. This was 1 which I did like this. This was 2, this was 3, this was 5, and this was 4. Okay, I'm back again. Now I have to fill the entries of this. How I will follow? Hope you remember the equation. What is that rule? Aij is equal to +1 is equal to -1 is equal to 0. Rule. This is called as a rule of entry of elements into matrix, impedance matrix. How is that? Ith element is incident to jth node and oriented away from j is +1. Ith element is incident to jth node oriented towards j is -1. Ith element is not at all incident to jth element, it is 0. Hope you remember it. Therefore, if I use this concept, what I can do? Come to the element number 1 and column number 1. Bus number 1. Where is bus number 1? I am here. How many elements are over here? Element 1, element 2. Only 2 are there. I will apply the rule. Is element number 1 is incident? Yes, incident. How it is oriented? Towards or away? It is, if it is incident and away, it is +1. Incident and towards, it is -1. Then it must be -1. So I position under the column 1, element number 1, which is -1. How about element number 2? Is element 2 is incident over here? Yes, incident, connected. How is it oriented? Away from that. Then it must be 2 under this column +1. Incident and moving away, +1. How about remaining element? Is there any element other than these two? Nothing. Then I'll simply make my entry zeros. Not incident, not incident, not incident. This is how A matrix can be filled. How about second bus? I move to this bus. I stand here. At this bus, 2 is incoming, 3 is outgoing, 5 is incoming. Remaining 1 and 4 are 0. 1 is not incident. Then I will fill 0. 2 is incident and incoming. Incoming means -1. 2, 2. This must be -1. How about element number 3 at this time? 3 is incident but going away from this bus. It must be +1. How about element number 4? Bus to element 4. No connection. This is 0. How about element number 5? Connected and towards that, oriented towards that means incoming. It must be minus. So rule I have to follow. AIJ rule, I should do it. So when I do not incident, incident and towards, incident and away, not incident, incident and towards. I can tell it simply by looking the element value. Now I will repeat it at bus number 3. At bus number 3, how many elements I have? 3 is incoming, 4 is incoming. Remaining all are zeros. 3, 4, only incident. So I should go directly 3. Under 3, stop at 3. This is incoming. It must be -1. How about 4? Incident, incoming. 4 is also -1. How about remaining entries? It must be surely 0. I can dump directly 0, 0, 0. Because they are not at all connected to bus number 3 over there. Now I will repeat it for bus number 4 also. Suppose I may tell you now, to save time, what you can do, directly matrix A you can do. When you want to do A, as it is a reference, you can delete this now itself. Don't do fourth bus calculation at all if you really want in this way. Suppose you want to make ensure I have done perfect work, I have deleted the perfect column like that, let us do and remove it. If not, you would like to do directly A matrix, this is a stop point. So no need to do, stop here itself. So for me, I am doing first time, I just make A cap and I will convince you, I delete and I make it as A matrix. Now, when I go to fourth bus, how many elements are there? 1 is outgoing, 4 is outgoing, 5 is outgoing. What is not connected is 2, 3 are not connected. So I will fill 0 for this first. At 4, 2 is 0. At 4, 3 is 0. Remaining 1 is connected outgoing. 1 must be +1. How about 4? Connected outgoing, +1. How about 5? Connected outgoing. All are outgoing here. There must be +1, +1, +1. You did it. Actually, what was your need? A matrix. So therefore, the reference bus you have to delete. This you have to delete. You have to cancel this. You have to cancel that particular column. Then this is going to become A. Now you got to know why I did A cap means it is not that fourth bus. Sometimes bus 2 is reference. Suppose this is your reference. What you will do? Column number 2 you will delete, remaining you have to compact. This you delete and arrange the space. Suppose bus 3 is reference. Third column you delete, remaining you arrange. Like that you may need to do. In that perspective, my advice of making A cap is very easier and useful. Hence I am advising you, prepare a full house matrix. From that full house matrix, whichever the column you don't want, you delete it and arrange the space properly. That becomes your necessity. So of course this is justified. If it is the fourth column, last one, don't do it. It is an easy way. If it is a central column, any one of the bus in between, then it becomes a little ambiguous how to do it, whether I am right or not. That time my sincere advice is do full house matrix. Whichever the column you want to delete off. A matter of 30 seconds to 40 seconds extra on your computational time, which ensure your path is perfect. So no matter whether it is a third or fourth bus reference, doing full house and deleting is a best and advised way. So therefore, when I did a reference bus deletion, I take out as per the problem given. So I delete this. When I delete this, my work is I reduce. I delete this. I don't require this because I have made the correction here A. When this is A, my matrix is ready. Clear? So it will become 5 cross 3 matrix. Now A is ready for me. So I got Y, I got A. Getting A transpose is changing the rows to columns. Then take mathematical product of A transpose into Y PRI into A. So that will give you the Y bus of the system. So what is the dimension there? So dimension stands as number of buses minus 1, 3 cross 3. So what I will do? I will take out this portion. I will reassemble all the matrices and I will do it. So I will just take out all these things. So I am just taking the main diagram, not required for me. Okay. I will just take out this also, not required for me at this time. Only required thing is A transpose and Y PRI. So I write here Y bus is equal to, what is A transpose? Transpose of this. I make it as a matrix of what? Rows to column interchange. Minus 1, 1, 0, 0, 0. This is the dimension. I just place the bracket here. The second row is 0, minus 1, 1, 0, minus 1. This is 0, 0, minus 1, 0. I just took a transpose of this. So I just made it as A transpose into Y. This matrix I multiply here. This is 5 cross 5, 1.4, 0, 0, 0, 0. All the 5 elements I put here. Okay. Second element is 0. Second is 1.6, 0, 0, 0. And third row 0, 0, 2.4. 0, 0, 2.4, 0, 0. And next is 2.0. 0, 0, 0, 2.0, 0. Okay. The last one is 5 cross 5, 1.6. 0, 0, 0, 0, 1.6. You can see I have replaced in this position matrix Y, which is Y primitive. I took this matrix over here. Then I will delete this also. I don't require this. I want space for my optimal workout. Into A I have to do. A transpose into Y into A. What is A matrix for me? A matrix is a matrix of incidence of elements with the particular buses. I will just redraw the same thing. Minus 1, 0, 0. Next is 1, minus 1, 0. 0, 1, minus 1. 0, 0, minus 1. 0, minus 1, 0. Now, I don't require this also. I delete it. Now, I am over here. What is this now? It is A transpose. This is Y primitive. This is A matrix for me. A transpose Y into A matrix. So now I have to make. What is the dimension of this one? This is 3 cross 5. This is 5 cross 5. This is 5 cross 3. Now you can see mathematically inner matrix dimensions are matching. 5 is matching with 5. 5 is matching with 5. What is the extreme dimension? 3. Extreme dimension 3. The final matrix will be 3 cross 3 only after the product. Which you have seen. The problem was having 4 buses. One of the bus was said as reference. When the reference bus was deleted from the representation, remaining buses were n minus 1. 4 minus 1 would be your dimension of the total final matrix. So therefore, I would say 3.3 cross 5, 5 cross 5, 5 cross 3 represent you finally by taking the product of these as a 3 cross 3 matrix. So if I place this answer. So I should see, I can do. It is your choice now because these two are multipliable. 5 cross 5, 5 cross 3. 5 is 5 matching. I can take a product of this, simplify, bring that simplified version over here. Let me write here. This would be like this way. A matrix and a simplified matrix for this. This is 3 cross 5 and this must be 5 cross 5, 5 cross 3. This must be 5 cross 3. When I take a multiply this one, 5 and 5 matching, this would result you a matrix 3 cross 3. 3, 3, 4. Clear? So now mathematically if I obtain, I have this answer. When I take this product with this, I have the answer. Let me write if you want over here. I will write it on the board, okay? It will be easier for you. This will be equal to, I rewrite, minus 1, 1, 0, 0, 0, 0, minus 1, 1, 0, minus 1, 0, 0, minus 1, 0, as usual. And first row multiply with first column. You will get first element over it. Let me write here. This will be like this. The element over here is minus 1.4. You can see 1.4 is product with minus 1, minus 1.4, 0 with 1, 0, 0 with 0, 0 with 0, 0 with 0. So whole sum represent only minus 1.4. Then I have similarly 1.4, 0, 0. Then this represent you 1.6, 1.6 minus and 0. You can verify by product of two matrices how you take mathematical operations. Minus 2.4. So let me write this as 0, this as 0, this as minus 2.0, and the last one is 0, minus 1.8, and this as 0. You can see this is a product of two matrices, Y and A. If I operate, this could be a resolution because it is 5 cross 5, 5 cross 3. It should result in me 5 rows, 3 columns. 5 cross 3 is my output. This is 3 cross 3. So when I take this product with this 3, this must be 3 cross 5. There's 3 rows, 5 columns. 3 cross 5, 5 cross 3 matrix. This should lead you the final solution. So you can cross check if somebody would like to verify. First row, when I multiply with this, that is the first element. First row, when I multiply with the second column, second element. First row, when I multiply with the third column, there is a third entry over here. This is changing the elements into 5 cross 3 pattern. When I take a second row, product with the first column, you can see 0, 1.6. This is multipliable with the 1 only. Hence it results to 1.6. When the same second row with the second column, when I multiply, only this is non-zero. 1.6 multiplied with minus, it becomes minus 1.6. And third position, here there is 0. 1.6 and 0 was 0. So it's a mathematics you can use. When you simple matrix multiplication technique if you use, you are able to get. And when I operate this, my final conclusion, 3 cross 5, 5 cross 3 should give me 3 cross 3. Again I will take first row, multiply with first column. First row with second. First row with the third. I will get 1, 2, 3. 3 elements. First row, first column, first data. First row, second column, second data. First row, third column, third data. I'll get 3 entries in the matrix. So slowly I'll repeat. Second row, first column, first entry. Second row, second column, second entry. Second row, third column, third entry. You will get here. The same thing when I take a third row, first column, multiply first entry. third row, second column, second entry. And last entry, third row, third column entry. So I will have full house matrix of 3 cross 3. So that's how Y bus can be 3 cross 3. If I split this, look into this, there is a minus 1 with 1.4. It is minus plus 1 into 1.4, 1.4. And there is a sum 1 with 1.6. It works out as 1.4 plus 1.6, which results to 3. So here comes the value 3. How about first row, second column? This is multiplying. Minus 1 is multiplied with 0, 0. 1 is multiplied with 1.6 minus. Rest all are 0. Hence, definitely this position I will get minus 1.6. And when I take multiplication of first row with the third column, you can see here non-zero, 0. Here 0, 0, product goes 0. Non-zero, but zeros over here, non-zero. Doesn't result anything. This will go 0. So first row, first column, first row, second column, first row, third column. If I go ahead, I'll be representing this. So same way, if I go with the second row, first, second row, second row, third column, I would get without fail minus 1.6, and I have 5.8, and I have minus 2.4 likewise, and 0, and it is minus 2.4, and the final one is 4.4. This is your standing answer. Y bus software gives problem ends here only. See, the steps were very simple. Of course, we got very detailed interaction with the first problem. When the problem is posed with you with this preliminary, you must be able to work it out. So what is the dimension ultimately? 3 cross 3. We had 5 cross 5 A matrix or A cap, and from which we took the answer. 5 cross 5 matrix was your Y primitive matrix. A matrix was 5 cross 4. When we deleted that column, it became 5 cross 3. And we use the product of A transpose Y into A, we could get the answer. So likewise, however is the problem? Problem looks apparently lengthier, but very simple in logic. Okay. So in the next class, we go ahead with one more problem, which may have coupling. Here, Y primitive is having only diagonal elements. The zeros are here, upper triangle, I can see here. This is upper triangle. This is lower triangle. Upper triangle, lower triangle are perfectly zeros here. If there exists a mutual coupling, then definitely one of these elements or one of the element is coupled with another. 2 entries are non-zero. 2 entries are non-zero. Such a problem also will take up, and we will try to see mathematically you will get some more entries here. Some zeros will find here. These zeros won't be zeros. Some physical number will come over there, and the product of that mathematically lead to a same one. But calculation wise, there is no change. Only the position wise values will reflect their nature. That's all. Okay. So this